The question says in hexacyanomanganate 2 ion, this is the oxidation number of central metal atom. The manganese atom assumes D2sp2 hybrid state. In the sense, here we have D2sp2 means a strong field ligand is present, and in the presence of strong field ligand, pairing of electron takes place. Pairing of electron takes place. Okay. So first of all, we write down the chemical formula of the complex. Okay, pay attention carefully. We have how many ligands? Hexacyano means we have cyano group is there, unidentate negative ligand, whole 6 is there. Okay, and then we have manganese is there, manganese, this is what manganese is there, and overall charge we do not know what is the charge. So we can calculate, because manganese oxidation number is what, 2, Cn is present in -1 oxidation number. Now pay attention carefully. O is equal to X is there. Manganese is present in +2 oxidation number, and plus there are 6 cyanide group are there, and each cyanide is present in -1. So this is what +2, and this is what we get -6. -6 is equal to X is there. So we got X is equal to -4 is there. Okay, so overall charge for this complex will be -4. Very interesting. So we got -4 is there. This is the complex we have, -4. This complex we get. Okay. Now it says the number of unpaired electrons in the complex is, means it is asking about the magnetic properties. Magnetic properties. Whenever the question is asking about hybridization, geometry, or magnetic properties, always use valence bond theory. Okay. To apply valence bond theory, we follow the simple steps. Now pay attention carefully. First step, you have to write but oxidation number of central metal atom already given in the question. It is present in +2 oxidation numbers. Okay, next you have to write electronic configuration of central metal ion is there. From here we get Mn2+. This is what central metal ion. Okay, we have to write electronic configuration, and next we have to write orbital notation for the central metal ion. Okay, and in the last you should consider the effect of ligand, whether strong field ligand is there or weak field ligand is there. Strong field ligand is pairing of electron, already I have written. Okay, the pairing of electron will be taking place. So first step is done already. We move on to the second step, writing electronic configuration for the central metal ion. Okay, so manganese atomic number is what, 25. So 5 will go to D orbital and 2 will go to S orbital. This is how we write outermost electronic configuration. It is having +2. We have manganese, sorry, it is manganese +2 is there, losing how many electrons? 2 electron. It is losing electron from S orbital. So we get, this is what, 3D, 5 is there. Okay, second step is also done. Then we move for the orbital notation. Okay, before writing the orbital notation, you should consider the effect of ligand. Okay, so let's complete. We have orbital notation. Okay, third step, orbital notation. So this is Mn and it is 2+. Electronic configuration is what, 3D, 5 is there. D orbital, how many boxes? 5 boxes are there. Okay, 3D, 5 is there. Then empty orbitals, 4s. Then we have next 4p is there. 4p. Now pay attention carefully. Before filling these 5 electrons in the D orbital, you must consider the effect of ligand. What kind of ligand? We have cyano. In general, any ligands starting from C or N considered as a strong field ligand which causes pairing of electron, means we do not follow Hund's rule. Okay, in pairing we start filling the electrons. So you can see 1, 2 paired. Okay, 3, 4, and it is 5 is there. 5. So you can see in the question we have to calculate the number of unpaired electrons. After considering the effect of ligand, this is what we have, orbital notation. Paired, only single spin is there, single, only one unpaired electron is there. You can see by following these steps easily we are able to answer this question. Okay, so you can see number of unpaired electrons we have only one, hence option D is correct. Very interesting question. If you like this video, please share and subscribe to the channel.